The next aspect of valence orbital theory we are going to treat now is hybridization. What is hybridization? The word hybridization simply means what? Blending or mixing of two or more orbitals of the same energy level together to form a new orbital called hybrid. That is hybrid what? Hybridization. This is the what? Mixing or blending of two or more orbitals or what? Orbitals, blending or mixing of two or more what? Orbitals of the same energy level or of the same principal quantum number or of the same what? This principal quantum number, you can replace it by what? Bracket or say what? Energy what? Energy level. You can remove this principal quantum number and use energy level to produce new orbital called hybrid. So the process of blending of what? Of two or more orbitals together of the same energy level to produce a new orbital called hybrid is called hybridization. Take for instance now, assume we have what? One s orbital and blend with what? With p orbital to give us what? Sp orbital or s orbital with ps and py to give us what? Two what? sp2. So the process of blending or mixing these two orbitals together to give me this is called hybridization. Or the process of mixing these three orbitals together to give me this is called hybridization. Or we have what? S orbital plus what? Ps plus py plus pz to give me what? This. To have s to have sp what? 3, the process of mixing them together to give me this is called what? Hybrid what? Hybridization. So the process whereby we mix two orbitals together to give us new orbital, the process is called hybrid what? Hybridization. And mind you, the orbital that you want to mix together, they must have the same energy level. We have explained that in the right energy rules on overlapping of what? Electron under valence orbital theory. So that is what? If you want to mix this now, if this one is 2s, this one must also be in what? 2p. You cannot mix 2s with what? With 3x, 3p. No, the orbitals must have the same principal what? Quantum number, which is what? The energy what? Energy number. That is hybridization. Then let us look at the what types of hybridization we have. Types of hybridization. So number one, we have SP hybridization. I what? Hybridization. Number two, SP square hybridization. Number three, SP3 hybridization. Number four, SP3D hybridization. Number five, SP3D square hybrid what? Let me write it in full. I what? Hybridization. Hybridization. How what? Hybridization. Hybridization. So those are the basic five types of hybridization we have. Assume in organic chemistry, if you ask what are the types of hybridization we have in organic chemistry, we have three. First, one, two, three hybridization. But in inorganic chemistry or physical chemistry, we have what? Five types of what? Of hybridization. Let's take it one after the what? The other. Yeah. The first one is sp hybridization. Sp what? Hybridization. This can be defined as a blending of one x orbital with what? One p orbital to produce the new hybrid of two p what? Orbitals. So what? This is the what? Blending of one s what? Orbital with one p orbital to produce sp new orbital, which is what? Hybrid. And the shape of sp hybridization is what? Is linear with angle 180 degree. And this sp hybridization can be found in example of molecule which undergo examples are we have what? BCl2, we have C2H2, which is what? a T. A time. So let us look at what the scenario that is happening here. We have what? One s orbital blend with what? P what? PS, and the hybrid is what? SP. What is the hybrid? The hybrid is what? SP. But if we want to look at the what? The real reaction of this, Abi, I believe you can have it in this form. The X, if S what? S orbital, this is X orbital overlap with what? P. This is S what? Orbital. And overlap with what? P orbital. When it's overlap, it will give us what? Two molecules of what? Of this. So when this now try to what? To rearrange, it will now form something like what? Like this nature. And this is what we call what? S what? S P. Call what? S what? X P. You can see that what? The SP is what? This SP. If I want to show you the what? The chemistry of this reaction, how the what? The SP what? Form. And I remember I said that beryllium chloride and ethyl, they are example of what? Of this SP hybridization. Let me use that one as a case of study. Beryllium here, no Be, beryllium, B2Cl, it will give us what? BeCl, C what? Cl. Can see that what? The angle here is angle what? 180. And the shape is what? Linear. But if we use what? C2, H4, H2, which is what? Ethyl. Ethyl is this two carbon, 1, 2, 3, H, H. So the bond on this is what? Is also what? 180 degree. And the shape is also what? What? Linear. But let me just show you the what? The chemistry of these two shapes. So the remaining hybridization, I will show the what? The scenario that is happened in the hybridization. But let me just show it here for you to understand the full concept of the hybridization. Let me say for what? For formation. For formation of what? Of B2Cl2. For formation of this now, do you know that what? We have B what? Beryllium react with molecule of what? Of chlorine to have Be Cl2. Have you now? But the configuration of beryllium is this. Let me say beryllium Be of beryllium Be, which is atomic number 2, its configuration is what? 1s2, which is what? This is 1s2, and the other one is what? 2s2. This is 2 what? S2. Under P, we have empty. Sure. The number of electron here is what? Is 1, 2, 1, 2. So, what we have here, we call it what? Ground state. State configuration of what? Of beryllium. So when the beryllium is what? Is in a state of exact state of what? Of excited or promotion. It will have what? 1s2, 2x, and we have what? P to be in this form. This is what? 2, let me split it. 2px, 2py, 2pz, or P. Abi? The same thing we have what? 2px, 2py, 2pz. So when is what? It's being what? Excited. Ground state and what? Excited. State of what? Of beryllium. At excited state, we have 1s2 electron here. Out of the 2 electron we have here, one we promote. This one we what? We promote from here and come to what? To this side. We now have what? 1 electron here. So if we have 1 electron here, so it simply means what? At this particular place here, we have what? For this x here, we have 1x, we have 1 what? 1x. So you can see that what? This is x orbital, is 2x. This is p orbital, 2p. They are the same energy what? Energy level. So this is the ground state of what? Of beryllium. So at this level now, if I'm now trying to what? To mix the orbital of 2x and these 2p together, if I mix it together, it will now give me what? sp hybridization. So this x here, this x that we have here, this is the structure here. I'm talking of this x. This is what? Is it here? The p, this is the structure here. Learn the later form. Let me draw it now. This x is here. 2x with 1 electron. Abi? Plus px. This is the structure of px with 2 ps with 1 electron. When they will now what? Overlap. We have what? 2 of this form, at the end of the day, they will give you what? This kind of structure. So, and this structure that we have here now is what we call what? S orbital. SP orbital. In this orbital, we have one electron here. The one here is spin up. The other one will also was spin up here. This is what we call what? Berry what? The hybridization of beryllium. But don't forget that what? This beryllium want to react with what? With chlorine. Abi? Want to react with what? With chlorine. And you realize that what? This chlorine have what? Configuration of what? 2, 8, 7. Abi? Let's check configuration for what? For chlorine. The chlorine that is what? Beryllium react with. Chlorine is what? Is 2, but let me write first one. Is 1s2, 2s2, 2p, I supposed to use fluorine. 2p6, have what? 3s2 here, then followed by what? P10, you need 5. 3p5. Let me put the electron there. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17. Yes, good. You can observe that what at this 3p here, we have what? 1 electron for the first chlorine. The same thing applicable to what? To the second what? Chlorine. When we have 2 chlorine in the reaction. Where is it? Here. So the same thing we have there. But do you know that what? This P orbital, if you want to draw the structure normally, the P orbital here, you can draw the structure in this form. If you can still remember, this is done what? Dumbbell. For this one, dumbbell here, we have it in this form. So this dumbbell is represent this last P here. Here we have 2 electrons here, Abi, 1, 2, 1, 2. This side we have 1. So this side we have what? 1, 2, 1, 2. Here we have 1. What we now do now? This is what? Chlorine. This one is also what? Chlorine. We will now draw it in this form. Let me say my first chlorine for the bond is what? Is this. So plus the sec sp plus s what? Sp, and we have what? Plus another what? This. You know what is happening here? This one we have here, this is what? Now let me put the electron. 1, 2, 3, 4. Here is what? Is down. The electron we have inside this place is what? Is up. What you have here inside this place here is down. 1, 2. We have what? 1, 2 here too. And this is what? Chlorine plus what? Beryllium plus what? Another chlorine. So when they now add together, you will now have what? Here, it will now give me what? This with this. Then overlap with this one. And this is also overlap with what? With this. And we have Y, we have X. So when they overlap, you will now have what? No. We have two electrons here with 1, 2. Here to 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So you can now see that what? This is what? Chlorine, beryllium, what? Chlorine. So this, what we have at the middle here is what? Is beryllium. This one is chlorine. This one is what? Is chlorine. So this is what? The molecular structure for BFCl. But in summary, what you just need here is what? sp hybridization comprised of what? One s orbital with one p orbital. What is angle? Trigonal. The shape is trigonal. Angle is what? Is 120. Can be found in what? In ethyl and what? BCl2. That's all. Yeah, what the second hybridization? The second one now is what? sp what? No. Let me use black pen. The second one is sp hybridization. sp2 hybrid what? Hybridization. So this one is what? This is the blending of one s orbital of what? One s orbital with two p orbital to form new orbital to form new sp square orbital. That is, here now, one s orbital blend with px, blend with py. When they blend together, we have two ps square orbital. And the shape here is trigonal. Sorry, that time. The shape of this one is linear. Angle is 180. The shape of this one is what? Trigonal. And angle is what? 120. Example of molecule here are BF3, BCl3, and we also have what? Alkene. Especially which is what? Ethene. Which is what? Alkene. Example of alkene, that is a what? Ethene, which is C2H4. This sp what? Hybridization. Let us look at it now. For this BF, we have done it under Vesper's what? Theory. So the hybridization is used to what? To determine the shape of molecule. So, and the angle here is what? The angle here is 120, 120, 120, and the shape is what? It's trigonal. And we can also have it in what? In 18. This is 18 now. H, 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 H. So the angle we have in 18 here, our angle here is angle what? One what? 120. And the shape is what? What? Trigonal. And again, you can ask in this 18, how many pi bond and how many sigma bond can be found here? Please, I forgot to treat it under pi bond and sigma bond. How to determine number of pi bond and number of what? Of sigma bond. So please note, any bond between hydrogen and a what? And carbon, or any element, the bond is what? Is sigma. Or any single bond that exists between any element or any atom of an element is always what? Sigma. Sigma bond is always what? Single. So if the bond is now the what? Is more than one, the remaining one are what? Are pi. Take for instance now, in this 18 here, how many pi bond do we have here? This first bond you have here is what? Is sigma. The one up here is what? Is pi. This one is sigma. This one is sigma. This one is sigma. This one is sigma. Sigma is a what? Is a single bond. A molecule that have two what? Two bonds must have one sigma, one pi bond. A molecule that have what? Triple bond must have one sigma bond. The remaining are two pi. Look at this compound now. Yes, this one that we have what? A carbon triple bond carbon like this. This bond between carbon and hydrogen here is sigma. Sigma. This one down is also sigma. The remaining two up here are what? Are pi. Please. So this is what? SP. Now the next one is SP3 what? Hybridization. So SP3 hybridization. SP3 hybridization. This is what? Mixing of one x orbital with three p orbital to form sp3 orbital, and the shape of this molecule hybridization is tetrahedral, and angle is 109.5 degrees. Example of molecule. What's the example? Example are sp3 what? Hybridization. Example are methane CH4. Example of sp3 hybridization, we have what? Ammonia. Example, we have what? H2 what? H2O, water. But for this sp3 hybridization, look at it now. S orbital plus px plus py plus pz to give you what? sp3 hybridization. So one s orbital blend with what? 3p orbital, sp3. That's it. So let us look at the what? The shape. So I said what? We can use methane, which is what? See this. This is the shape of tetrahedral, and the angle here, sorry, is 10. The angle here is what? Is 109.5. So this tetrahedral shape of what? This is the what? Methane. So this structure here is what? Is ethane. Okay. And we can also have it in what? In, what should I call it? Yes, H2O. If you look at H2O, we have what? Water, and have what? Low pH here. So this water, the shape, sorry, the angle here is what? 100 what? 105. So the hybridization of water is what? sp3. But the shape of water is angular what? Angular shape. But the hybridization of what? Methane is what? Is sp3. But the shape is what? Tetrahedral. Please. The same thing happened to what? Ammonia. If you look at what? Ammonia, which is what? H, 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 with low pH here. The hybridization of what? Of ammonia is also what? sp what? sp3. But the angle of ammonia is what? Is 107. So the ammonia, methane, water, they have the same hybridization. The next hybrid is what? sp sp3d hybridization. So for this is a blending. This is a blending of what? One s orbital plus 3p orbital, ps, py, pz, plus D. Blending of one s orbital with 1p with 3p and a 1d orbital to give us what? sp3d hybrid. That's sp3 hybridization. And this hybridization, the shape of this hybridization is trigonal. The shape is what? Trigonal bipyramidal. And the angle of sp3d hybridization, what is the angle? Angle is 90 degree, 120 degree. And this kind of hybridization can be found in what? PCl5 and PF5. What is the what? Their shape. We have done their shape too in what? In first part theory. We have phosphorus here. We have what? Chlorine here. We have one chlorine here, one chlorine, the next chlorine, the next chlorine. So I now say what? The angle here is what? Is 90. But the angle between what? The angle here is 90. But the angle between this side is what? 120 degree. This is the shape of what? Trigonal by what? By pyramid. And the last one is sp3d square hybrid what? Hybridization. So this one is the blending of one s orbital with px plus py plus pz plus 2d. So it will now give us what? sp3d square. And the shape for this hybridization is octahedral. What is angle? The angle here is 90 degree. And it can be found in a molecule of XF6 or XCl6 or ion CN6. So this is the shape of this what? Of this molecule. Sulfur, this is what? The shape. And the angle there is what? Angle 90 what? Degree. So that is all about what? Hybridization. Hybridization is a blending of two or more orbitals together of the same energy level to form new hybrid. Hybridization, there are 5 types: sp, sp2, sp3, sp3d, sp3d square. That's all about what? Hybridization and their example and their what? Shape.